Okay, equal values and substitution. Equal values and substitution are very similar to each other. They look the same. It's just they're just different ways of looking at the same problem. Let's start with equal values because that's what the book teaches us first, and I guess it makes sense to put it first. Uh, Generally, you would start with equal values with a problem that would be of the form like y equals 2x plus 5, and, and y equals something else like 3x minus 6 or something. Where you have two equations equal to the same thing. Okay, they're both equal to y. And my example in class was I had three people of the same height basically. And I said these two people are equal in height. And these two people are equal in height. So I can bypass this middle person and just say the first person and the third person are equal in height. So in this case, this middle person right here is the y. Okay, this person equals y. This person equals y. Well, if they both equal the same person, or the same height of the person, then they both must equal to each other. So that's what we're going to do with equal values. That's how that works. Now the problem is if it's not in the form y equals and y equals, like this one isn't right here, we have to do a little extra work to start. So we need to put it in the form y equals something, or x equals something for that matter, but we'll do the y because this one's equal to y. So let's just solve this one for y. So put the 4x on the other side is the first step you need to do. So it reads y equals 2 minus 4x, or negative 4x plus 2. Okay, and then kind of ignore all this then, and just look at these two equations. Now they're both equal to y. There's my y, there's my y. Well, if they both equal the same thing, they must both equal each other. So you make this and this equal to each other. Negative 3x equals 2 minus 4x. And then solve it from there. Okay, I'll go through this part kind of quickly. I'll go plus 4x here, plus 4x, 2 equals 1x, which is just x. So x is 2. I'm not going to circle that yet. Now x is 2, but we're not done with the problem. We just solved for x. These two original equations that we had up here, get rid of this too. These two original problems are lines, okay? Like this y equals negative 3x roughly looks something like this. And y equals, if I do this, the slope-intercept form, y equals negative 4x plus 2 crosses up here, and then it goes down 4 over 1, so it's a little steeper. So they're going to cross eventually, by perfectly straight lines, of course. Somewhere they're going to cross. That point is an ordered pair. That's an x and a y. We only found the x value of it. So we found that this is 2, like this is 1, 2. We have to find this point down here. So we simply plug in that 2 into either equation. It'll work in both of them. So negative 3 times 2 is negative 6. So my y value is negative 6. And I'm going to ask you to write all of these problems if they're representing lines, or if they use x's and y's, x's and y's especially, write them as an ordered pair. 2, negative 6. That's what I want for an answer. Okay. And if to double check to make sure you're right, if you have time on a test or whatever, you plug in that same 2 for the other equation. 4 times 2 is 8. 8, what am I doing here? I'm sorry for 8 plus y equals 2. So if I subtract 8, I get y equals negative 6. So you got the same answer both times. As long as you get the same answer both times, we're good. Then you know you did it right. You write your answer as an ordered pair, and you are finished. Now that's equal values. Substitution is, it'll look the same when I'm done, but it works differently. And actually substitution in this particular case won't look the same because it's just going to work a little bit easier. Right here, substitution. Y is negative 3x. So wherever I see y in both equations, for that matter, I can replace it with negative 3x. So I'm going to go to the other equation and rewrite that second equation with a negative 3x in the place of y right here, in this whole spot right here. So plus negative 3x, because I'm substituting negative 3x for the y, because they're equal. And look at that problem. Now let's solve that. That's just 1x. How cool is that? So x is 2. and then plug it back in like we just did a second ago, and we get y is 6, or negative 6. Okay, that's substitution. Let's do this one equal values method. Okay, equal values, again, we have to make them both equal to the same thing. So subtract 2x, subtract 2x. Now this is y equals 13 minus 2x. So now they both equal the same y right here and right here, which means this stuff must equal that stuff. So you write 7x minus 5 equals 13 minus 2x, and then solve it. So if I maybe add 2x to both sides, just bring that over there, I'll make that 9x. I add 5 to both sides, I make that 18. Now this part I'm going to start going through a little quicker, because you should have had some practice at doing this up before this point. And then I'm going to divide both sides by 9 right here. I get x equals 2. And don't forget to plug it back in, because we have 2 equations to plug it back in for, to find the y value. So I get, what is that, 2? So 2. So 7 times 2 is 14. 14 minus 5 is 9. So I get y is 9. And you'll lose some points if you don't write the ordered pair. So make sure you write the ordered pair. 2, 9. Let's double check. If I plug it in the 2 for the other equation, 2 times 2 is 4. 4 plus y is 13. Subtract 4 from both sides, I do get 9. So it checks. So that's equal values, where you solve them both for y, or for any letter for that matter. Let's show you how quickly substitution works here. Y is this stuff. That's y. So right in that spot, I'm going to squeeze all these things right in that one little spot right there. Recopy this whole equation. So 2x plus y, but y is now 7x minus 5. Maybe I'll put parentheses around to show you that this was a big y before. 2x plus y, okay? So that's 7x minus 5 here equals 13. So if it's confusing, all I did is recopy this whole equation. 2x is right there, the 13 is right there, the equals is right there, the plus is right there, and instead of y, I wrote this quantity. Okay, and you do need to write this as a quantity, because there are times when there's like a 3y or something that you'll have to distribute through there. So just a heads up on that. And then just solve this. Okay, now we don't really need the parentheses at this point because there's nothing in front of there. So we just combine like terms. So that's 9. Don't distribute the 2 because there's a plus sign here, right? Don't make it 14x squared. So it's just 9x minus 5 equals 13. So 9x equals 18. Conveniently comes out to be a nice number for us. So x is 2, which we found before. Plug the 2 back in. Right there's the safest place. 14 minus 5 is 9. So we have 2 comma 9. All right, hope that's pretty cool. Moving on. I think I have 2 more here. Oh, 3 more. I'll go through a little quicker here. Now in this case, it says x equals something. So I want to solve this problem for x, not for y. Okay, so here I'm going to put the 4y to the right side and get x equals 4y plus 23, or 23 plus 4y. Okay, now get rid of this, and now we have the 2 things they're equal to is x. So this equals this. This is the equal values method. Okay, so negative 5y minus 4 equals 4y plus 23. I'll put the y's on one side, so maybe we'll bring the 4y over there and make it negative 9y, because I'm subtracting 4y. And here I'll add 4 to both sides, so I get 27. I divide by the negative 9, and I get negative 3. That's my y value. And generally speaking, if you get whole numbers, you're probably right, or integers. If you get some decimals, you might want to double check your work, because we usually don't do decimals, but we sometimes do. Plug in the negative 3, probably in this first one is going to be the easier one. So I have x equals negative 5 times negative 3, which is positive 15, minus 4. So in this case, we found y first and x second, but be careful when you write your ordered pair. It's always x comma y. Always alphabetical order. Just because we found the y first doesn't mean it goes first. Okay. And I want to double check, make sure I did this work right. So if I plug 11 in, if I plug in negative 3 for y right there, I get x minus 4 times negative 3, which means plus 12. And then subtract 12 from both sides. That's 11. So x equals 11. So we've got the same answer twice, so I know we did it right. Substitution method. We simply take this stuff. Now it says x equals this stuff. So I need to plug it in for x, not for y. Whatever it says it equals to. Okay. So negative 5, y minus 4, and then copy the rest of this. Minus 4y equals 23. Combine stuff on either side. So negative 9y. Remember, this is plus negative here. And then now at the same step, I'm going to go plus 4 to both sides just to save a step. Equals 27. So y is negative 3. And again, plug in the negative 3 and I get my 11. And that's x. So 11 is x and y was negative 3. Same answer. So slightly different way. The substitution, I think, is a little quicker because you don't have to rewrite a different equation for the same letter. You can just plain plug it in right away. And two more. Here we go. Y equals this stuff. And we have to make this equal to y if I want to use equal values. So I'm actually going to put the y to the right side just to make it plus y. Okay, so I have x equals 1 plus y. So I don't have a negative y or the opposite of y here. And then subtract 1. So I actually have y equals x minus 1. So there's one equation. And then the original one up here is also equal to y. So if I take this y here and this y here and look at what it equals, well then this other stuff must equal this other stuff. So I write x plus 1 equals x minus 1. Well, it doesn't make any sense. Like, how can I take a number, add 1 to it, and have it equal to subtracting 1 from the same value? So this is going to be no solution. Whether you want to keep going and say, like, go minus 1, or just stop where I just stopped a second ago. Like this. Maybe subtract x. I get 0 equals negative 2 or 0x equals negative 2. It doesn't make any sense. You can't plug anything in for x to make it equal to negative 2 because it's always going to be 0. So this one's going to be no solution. Now, something that's kind of important that you need to understand, what does this no solution mean? Well, what's going on whenever I graph these lines, I'm not even going to look at the equations, I'm just graphing lines. These two lines are parallel. They never cross. If they never cross, there's no solution. They exist, but they don't cross. So there's no intersection point. So there's no ordered pair where they cross. So it just means they're parallel. And, oh, did I skip one? I skipped one. Let's go back to 11. And, oh, I want to do that substitution method on this one. Really dragging this out a long time, aren't I? Go ahead and skip ahead if you want. All right, this stuff is y. Substitution-wise, I plug it in for y right there. I don't have to rewrite anything. So x minus y, but y is now x plus 1. Right, this is squeezed into that little spot right there. So we copy everything except for this. I put x plus 1 in its place. Now here it is important you put parentheses because I need to distribute this negative sign. X minus 1 equals 1. And then here we run into our problem. The x's cancel. There's like x minus x is 0. I get negative 1 equals 1, which doesn't make any sense. So again, no solution because the lines are parallel. All right, back to the one I accidentally skipped. Equal values method. It's kind of old here, but I'll work through it. I guess we're going to solve for y. So here I'm going to solve for y. So I get 2y, negative 4x plus 6. I'm going to divide it out, everything by 2. So y equals negative 2x plus 3. And then this y and that y are the same. So I make this quantity equal to that quantity. So 3 minus 2x equals negative 2x plus 3. Now, if you can look at it quickly, you'll notice it's actually the same problem. This is the same as itself. But if you want to keep going and say like plus 2x here, over here, oh, that's 0 and that's 0, so I get nothing. And I get 3 equals 3, which totally makes sense. It always makes sense. Unlike the last problem, where it'd be like 0 equals 3 or 0 equals 1 or whatever. This makes sense. Or if I subtract 3, I get 0 equals 0. However you want to look at it. Whenever you get down to a problem where the variables disappear It's either well, I'm not going to say that here. It's either no solution, or before, when it was like one single equation, we'd call it all numbers. Like all numbers you could plug in for x would work. Here it's slightly different because we have a system. When we have a system of two equations, what's going on is, let's say this is our line. Well, the other line that's right here is the same line. So it's actually right on top of the other. And the intersection points, all these points are intersection points. There's an infinite number of intersection points. So what we typically would say is many solutions. Like we actually have to say how many there are instead of what they are. Or infinite solutions. It's like the only time I'd actually say infinite solutions for an answer. It's in a system. Don't say that for a regular, like, X problem. Like if this is our given problem in a different situation, then yes, all X's work. Any number works for X. But because this comes from a system, you got to keep in mind that this is actually two lines that are on top of each other. And there's many solutions that work. They don't all work. Like this X doesn't work. That X doesn't work. None of these X's work. So you can't say all numbers work. You can't say infinite X's work or something. You can say there's infinite solutions. These solutions that I'm talking about are actually ordered pairs, X's and Y's. There's an infinite number of them. You just can't list them. It doesn't make any sense. So that's kind of a tricky problem right there. All right, hope that helps. Thank you.